Any from this slot? Anybody had morning slot? Okay, fine. Hope you're able to see the screen.
Yes, sir.
Yes, sir.
Yes. So yesterday we touched upon the state model. We initiated the discussion on state modeling. We majorly looked at what is a state, how a state occurs, how to visualize a state in general, what is an event, the types of events, change event, signal event, time event, and we looked at how a state diagram can be written, how to understand, and we stopped at phone model, that is how a telephone line works, how to visualize rather a telephone line. So any doubts so far, if you have gone through and found any clarification required? So majorly the state diagram represents the objects, how the objects are moving, I mean rather how interaction happens between one object and another object as per the time is concerned, because state diagram is mainly for time bound. So at a given point in time, how the state of the activities are changing in a given class or a given object is what we normally picturize. So from that perspective, we had taken a telephone line as an example. So this is what we have seen. Any doubts so far? And we also know how to represent a class, a state, which is a similar to a class diagram, that is a box, rectangle box, but with a corners being rounded here. In class, it is a flat corner, but here it is a rounded corner. So that's how we have seen. And also the name of the class, name of the state diagram is left side, is written on the left top corner with a pentagon. You can see here a phone line we have mentioned, which is in the left top corner with a pentagon shape, which is nothing but the name of the state diagram. So otherwise, we have some good number of states connected through transitions from one place to another place. It looks like a flow chart, but this is not a flow chart, but it is a state diagram where based on some activity or some event triggering, how the transition or the signal pass from one state to one object to another object as a result of activities that happen in a given system. So if you have no doubts, probably we can move into the next concept called as a advanced state modeling, where we can look at some nested state diagram and stuff like that. So I can pause for a minute here. If you have any doubts, please let me know.
No, sir, in this, I don't have any doubts.
Yes.
Sir,
Yes.
So yesterday you gave to develop a state diagram for ATM.
Yeah, I'll come. Next task is that. First, I want to make sure whether you understood. So once you have no doubts, probably next topic is that.
So no doubts, sir.
Yeah, fine. Yeah. Now the ATM we have taken. So this is a very high-end picture. Don't worry about this, but you should have developed something similar to this. If any of you have done, probably you can let me know.
Yes, sir, I have done, sir.
Yeah. Can you present?
Yes, sir.
Yes. Yes, go ahead.
So is it visible, sir?
Yes, yes. See, more or less, advice here is don't use those starting and ending notations, because people get confused with the activity diagram. Normally we use the starting symbol, which is a solid circle, and the ending symbol, we call it as a bull's eye, which are normally used with respect to the activity diagrams. I think we have not discussed that as part of state diagram, so better you avoid them.
Yes, sir.
So you have seen how the telephone line we have picturized.
Yes,
There
sir.
is a complete rectangle box outside, right?
Oh, yes, sir.
You should put that box that shows that it is a state diagram. On the left hand side corner, top corner, you should write the name of the state diagram. For example, ATM. We have written phone line, you should have written ATM. So that shows that it is a state diagram. So this diagram, what you have shown, typically looks like a activity diagram rather than a state diagram.
Okay, sir.
Because of two reasons. One, you have used the starting symbol and the ending symbol, which are not part of a state diagram. Second, you have not kept them in the rectangle box, outside box, boundary. So these two will not confirm it is a state diagram. So they are mandatory. They are supposed to be written here with a proper name.
Yes, sir.
Otherwise, the state diagram concept looks good. Basically, the major concepts you try to incorporate as far as ATM is concerned. And ATM is a very big use case, or you can write many number of state or small substate diagrams. But this is a overall diagram what you can see, because there everything, the minute you insert a card, you validate the things, the capturing of the details, verification, then giving the flow menu for you. Choose in menu again. There are multiple: withdraw money, what to say, cash or change pin. There are so many. For everything again, it becomes another use case or another state diagram. So this is a overall picture, fine. But that's how we should be able to develop. So fine, it's good. If any of other students have developed, probably you can let me know.
So can I present?
Yes.
Sir, is that visible?
Yeah, visible. Are you able to show from right from insert is the starting point?
Yes, sir. Insert card.
Okay. Again, the
Then
same.
read card.
The outline is missing. You can write the outline box with a
Yes.
proper name for
Okay,
this.
sir.
Otherwise, don't give so many details, because the diagram is not properly seen here because of the content text.
Okay, sir.
So states should be visible properly. Of course, they explain us how the movement happens or the transition happens from one state to another state, but you can avoid or reduce the text part wherever possible, or you can make the diagram bigger. Otherwise, it's okay.
Okay, sir.
Yeah. Fine. So this is how the template. All of you can follow that and ensure that you understood, and you will be able to write a state diagram for the given scenario. So let me continue now. Hope the PPT is visible to you.
Yes, sir.
Yeah. So this is a wider or a bigger. So that's what I said. So your state should be visible than the text. Probably you can take care of that. Otherwise, this is the how we are going to have. So here, some of you are able to see the starting and ending. That is not right. Actually, you should not be using them as part of the state diagram. So don't go by that. So avoid these symbols, because no doubt they are going to be relevant, but with respect to state diagram, it is better to avoid them. Okay, it's fine. So this is actually the good state diagram, not these two, because they are written here for different perception. So for you I'm showing because how a state diagram can grow in complexity. But state diagram per se, we should not be writing majorly this unless it is required for some purpose. So we recommend not to use them in the state diagram. Fine. Now, coming to the next concept, where state diagram, we have a nested state diagram. So you might have seen nested concept in programming, maybe nested if, nested else if, maybe you're programming for loops where we have a nested for loop. So these are the concepts where a for loop within another for loop or a if within another if is going to be a nesting of the concept, or a class within another class is a nested class. So this concept is familiar for the IT student as you have been working on the programming. So nesting is nothing but having a similar construct within another construct. Maybe it's like a ladder, one within another one. So, or a class within another class, a constructor within another constructor, a destructor within another destructor. So like that, we have a nesting possibility. Similarly here, a state diagram also can have a nesting of states, simply because one state, if you consider, that might be split. For example, some of you have shown here now a menu. Menu is a one state, but menu state is going to have multiple other substates. So if you want to club them into or as a part of menu itself, then menu becomes a major state. Within that, there might be some of the other states which can be helping the menu state to progress or prosper. If that is the case, we might imagine a given situation as a nested case. Or if you take a vending machine, for example, which we have talked about yesterday, while dispensing some of the items, we can consider vending machine to behave or to have a state which can further have an additional state. Or we can consider the example what we have taken in the previous class, that is a phone line. If you look at the phone line started with idle, then we have become a dial tone and all. So if you want to differentiate, because if you look at that, the major states of a phone is idle state or active state. Even though we have clubbed all of them in a independent states, I can further divide them as a idle state of a phone or a active state of a phone. If that is the case, I can still bring some nesting of activities. Anything which is apart from that idle, whatever you see, that 11 plus odd states, I can club them as a active state. So active becomes another state within which there are 10, 11 substates. Like that, we can imagine a given system as a nesting of states, which is similar to the concept what I've seen in any programming, a nested if or a nested class or a nested for loop and stuff like that. So nested concept here is also valid, where you can have a class within a class or a state within a state. Or state diagram rather will also have a different state diagrams or states coming or comprising. So that is a concept. Let us look at those examples what you have taken earlier. So if you look at the vending machine here, so far how the states are written, states with the whatever the notation we have in UML, that is a rectangle box with the curved edges. We have written the name of the state. Now we can see some of the states are bolded here. So there is idle state, there is a collecting money state, there is a test item and compute change state, there is a make change state, there is a dispense. If you look at that, there are certain things which are made bold, and there is another concept, dispense item. So dispense item is going to be nested state here, meaning that you are going to expand this further so that this particular state is not a small state, it is going to be a separate state diagram henceforth. If that is the case, we can represent them. As we represented some of the classes and objects with the colon, we can represent dispense is actually the state here, but dispense item is being considered as a internal state, which is a nested state here. So that is the reason why this entire concept of dispense item is promoted as another state diagram. Hope you can observe here. So dispense item, which is a part of the vending machine state as one of the state, now has been promoted to become itself another state diagram. We can see dispense item. The minute I write like this is nothing but a state diagram which is having a boundary here. Within that, we have these concepts. So here, yes, we can talk about writing these starting and ending, because this is a sub part. This is not a major part, right? The major diagram of a state diagram does not contain the starting and ending button, whereas the sub nesting parts or substates probably we can have, because they are having some lifetime normally state diagrams are meant for a lifetime, but internally these are some of the substates which also will have a specific lifetime or specific activity. Probably we can use them. Otherwise, you should not be using them as and when we want, because they are mainly pointed in the activity diagram. Okay, so what our interest here is a state diagram. In our case, a vending machine can have another state diagram as a substate here, and that need to be promoted further as a state diagram. So if this is the case, we can bring in the nested state diagrams as part of the modeling. That is a state model, right? Yeah, let us take our own example of a telephone line. So this is the original telephone line what we have taken just now, where every state is independent. We have booked everything as one single state diagram. Okay. And second, we have rewritten this now. Same, there is no change, but you can observe here. So we have written this particular part. If you observe, this is identified as a new state, because this notation is for a state, and we have kept everything here as another state. And look at the name. The name is active. So what is here so far as a part of the single state diagram? Now we have divided into two. What is that? One is the idle state, other one is a active state. So idle state means you are not able to take the phone. Phone is off on hook now. So it is back to the normal state. But the minute you receive, or the minute you remove the handle, the receiver outside the phone system, we call it as a active state, meaning that you can start dialing, you can start conversing, you can do all these activities. So this entire part, I'm going to term it as an active state of a phone. Otherwise, it is going to be idle. It's only two states. So I'm bringing active state as a complete state, which has a dial tone, dialing, connecting, speaking, ringing. All those things are going to be part of your active state. So if you replace the receiver back to the system, probably we'll call it as a idle state. How is this possible? You can see this. There are so many arrow marks that are pointing towards the one state called as a idle state, and everything has been picturized in a single state. Only one arrow has been given. So this is maybe a further micro level representation of phone line keeping a nested state diagram. So this is how you can visualize a nested state diagram depending upon the requirement of the system. Yeah. Any confusion here? Any doubts here? How nested diagrams can be written? It is a choice. You decide how it should be. If you want to write, you can write. We have taken both the examples: state diagram without any nesting, state diagram with nesting. And you will appreciate here the major states. One is idle state, active state. Even same thing you can do for your ATM card. If it is possible to bring in this type of nesting, probably in the menu part you can try. Is it clear?
Yes, sir.
Yes. So next, this is another example, car. So you know the car gear system. If it is a neutral, if it is in gear movement, if it is reverse, all those things are there. When you are in neutral, you will come to from neutral state, you will come to the movement state, or a forward, first gear, second gear, third gear, whatever it is. Once you are going back to the reverse mode, you should go to the neutral, then only you can go to the reverse gear. I think most of you are aware of this automobile transmission, right? So you are in the neutral gear now. From that, you can go to either reverse gear or you can go to the forward gear. When you come to forward, forward is a bigger state, because within forward there is a first gear, there is a second gear, there is a third gear, or maybe fourth or fifth, whatever it is. So it depends on which automobile. Since it is a car, they have taken 3, maybe you can go up to 4, 5 as well, depending upon what type of car. But that is not our interest now. Forward movement itself is a bigger transition, or bigger state rather, which internally comprises first, second, third, fourth. Like if this is the case, probably I can start providing a nested. So there is a state here, state diagram. This is one state. Within that, there are 3 states: first, second, and third. So this is how we can represent a nested state diagram. Okay. So depending upon the type of system we are considering. So I want to inform you one point here. There is a concept called as a one-shot diagram. There is a concept called as a one-shot diagram. One-shot diagrams are more specific in nature. So one example is this. This is an example of a one-shot diagram, meaning that everything is picturized in this, and this will be having a very clear starting and ending points. So how to start and how to end, all those things will be very clearly provided. Similarly, I can take one more one-shot diagram. This is another one-shot diagram. So one-shot diagrams normally come with a starting point and a ending point. Okay. So that is what concept you can keep in mind. There are also state diagrams, but provided you mention this. Need not be mentioning the same symbol here. You can simply write start, S-T-A-R-T. You can write end here. So that is also fine. Because as I said, these symbols are not meant for the state diagram. They are meant for the activity diagram. So you can write start, end, all those. Okay. So, or sometimes people write for end this symbol. This is also fine. Any notation is fine, but if you represent them with a very specific timelines, as we do here, we call them as a one-shot diagram. Okay, just for your information. Yeah, this is about the nested states. Okay. Yeah. Next level, since we're discussing about the advanced state modeling, and we know that we have just now seen the class model, and advanced or any state model is mainly related to the objects, and objects are part of the class model, and there should be some relation between class diagram and state diagram, or a class model and the state model. When you want to represent a given class model as a further identification or further description through state model, probably we also should know how the generalization or how the class model can be used while in the representation of a state model. One such example is what we have taken. So how, if we have a class diagram with proper generalization, how we can take it up. So can anybody tell me what type of relationship we have between car and ignition, transmission, brake, and acceleration here? So what is the diagram is all about, the top diagram?
So aggregation.
Is it a generalization? Is it aggregation? Is it a composition? Is this aggregation now?
Yes, sir, aggregation.
Yeah, because the symbol is a diamond, not triangle. If it is a triangle, it would have become a inheritance or a generalization. Now it is a hollow
Yes, sir.
diamond, which says it is a aggregation. Perfect. So if we make this as a composition, then the meaning is different. What is the meaning of composition? It is a strong form of an aggregation where two constraints will be there. What are they? One is the lifetime of the constituents are completely depending on the aggregate object, and second is there is a one-to-one relationship intuitively. So that's how we have been seeing. And right now the discussion is, if there is a diagram of this category, which is a class model here, how do I take it up to represent into a state model? So this is how it is now. Okay. So car is a bigger state here, bigger model rather. So all those independent constituents have been brought here: ignition, transmission, brake, and accelerator. They have their own. So I can say each one of them as a one-shot diagram. They are the concept of a one-shot diagram. So they have very specific, information, a very specific data, very specific to what activity they are going to do. There are lifetime bound and having a connection with the associated item. So brake, if you press some key, some pedal, it will be, brake will be applied. If you release, brake will not be there. Over, start and end. Similarly, acceleration. If you take a car, if you press the pedal, you will have a acceleration being increased, or if you release that, probably acceleration will be reduced. Similarly, transmission, we have just now seen gear, how the gear can be provided, first gear, second gear, third gear, like that. And ignition as well, when you switch on through the ignition slot, through the key, ignition might be on, your system will be, your car will be in a running mode or a starting mode. If you switch off, release the key, probably it will back to the normal idle mode or a neutral mode. So this is how the representation happens. That means you can take a class model and you can start splitting, giving more information. Probably when you look at this class model, we know that it is going to give a very overview, top view of a model. How the objects or classes are related. But if you look at the state diagram, you get some more clarity how the relationship is taken to the next level with respect to the activities which are time bound. Time bound here means as you do some trigger some new event or activity, how the actions are going to take place inside the state. So this is completely a state model, whereas this is a class model. So class model gives an overview. State model is providing a further input on the how the interaction happens or how changes can be visualized or portrayed between the objects. So that's how we have to see. So this is how the relationship between a class model and the state model can be brought in. We call this as a behavior of a state model. The behavior of a state model can be visualized by taking class model as well. So you can take a class model as a reference and build your own state model to give a further details. Okay, so that is about the nested state model. Okay, yeah. So this concludes our state model concepts. Let me quickly check on the syllabus part if you have missed anything. So we know the events. We have seen the various types of events. We know how to represent the event state. We have also seen the transitions, and we have seen the guard condition. We know how to write the state diagram. And telephone line is very important in the exam. They normally ask for 10 marks. Represent telephone line through state model. So you have to write and explain at least 5 to 6 states. What is ideal state? What is the dial tone state? What is the connecting state? What is the ringing state? And stuff like that. Then we also have one shot diagram. Just we have discussed about that. So that is basically about state diagram. And also we have seen in the previous class, if you remember, taken the traffic signal model. Within the state, we wrote some line, do when signal is red and signal is green, when there is no car, when there is a car. So all those, they call it as a activities within that. So we can take the class, we can take the state model into the next level with a proper description. So these are all the things what you have seen in the previous class and today's as far as the state model is concerned. We also taken as ATM model or vending machine model as some of the examples to understand the models. And today we have touched upon nested states. Yeah, that is a major concept for today's, and how the aggregation can be visualized today with respect to the state model. That means how a class model can be further enhanced to get more inputs through the state model. So this is how we have seen that, and probably this concludes the state model. So before we go to the next model and the last model, that is interaction model. So if you have any doubts, please let me know how we can help you in understanding this. If you have any doubts, please let me know.
No, sir, no.
Okay. Fine. Take an assignment. Develop a state model. Develop a state model for BMSIT college website. Develop a state model for BMSIT college website in general and Department of MCA in particular. So I want more details about the Department of MCA link in the website, how we can majorly have. So have maximum 10 states, not beyond that. Okay. I'm in class. Anything urgent? Okay. Fine. So take college website, bring state model in general and in specific to the Department of MCA, right? So try to have maximum 10 states because there are so many navigations in the website. You need not worry about them. Take some of the important ones, maybe say maximum 10 of your choice. Choice is yours. Next. So next model, And the last model of the concept is interaction model. So we have seen how class model is going to be used. You know how the representation. So class model basically provides the overview of the system. Rather, it provides the relationship among the various classes and objects that are part of the system. It is like ER diagram typically. Next, state model. It also portrays or depicts or describes the transactions that are being held, but they are time bound. That means based on some activity. If this happens, what is going to happen? If this is not happening, how the system is going to look like? So that is the internal reactions or transmissions or transactions that are portrayed through the state model. Now we'll go to the next level called as a interaction model, where, as name says, the behavior now. So the behavior what you have seen in the state model is a time bound. Now the behavior what we see among the objects or among the various interdependent concepts of a model or of a system are going to be internal behavior. How a particular interface is going to behave internally. How interactions of a given system or a given internal specification is going to behave properly. So class model is an overview. State model is a time related or time bound activity, whereas interaction model is a generic behavior of objects in the system. So probably we'll see. And there are three diagrams that are associated with the interaction model. Okay. Yeah. So as we discussed, class model describes the relationship among the objects. The state model is a time bound, maybe life cycle that we have seen. The interaction model is the internal behavior between or among the objects which are portrayed. So there are three diagrams. If you remember, when we looked at UML, we identified 5-6 diagrams: class diagram, state diagram, use case diagram, sequence diagram, activity diagram, component diagram, deployment diagram, interaction diagram. There are so many diagrams. And majorly these diagrams are part of a complete SDLC life cycle. But our interest was related to these three models. There is a class model, has a class diagram. State model had state diagram, but interaction model comes with the three diagrams: use case diagram, sequence diagram, and activity diagram. These three diagrams are related to the interactions that are happening between or among the various objects. You will get to know further finer details. It is nothing to do with the lifetime alone. It is going to have further intricacies or inputs that are going to happen within or among the models. Among these objects. So that is the idea. So if someone asks you, what is use case diagram? Use case diagram is a part of the interaction model. What is an activity diagram? It is a part of the interaction. Interaction means how the objects are going to relate each other and what will be the activities that are going to trigger from one object to another object to have their communication between or among the objects. If that is the case, probably you can bring the interaction model in terms of use case, sequence, and activity diagram, right? So this is what we'll see one by one. So let us go to the use case model first, or use case diagram. Each one of them is a separate discussion. So we'll devote our good amount of time on each of them. So use case diagram. Okay. So first one. Yeah. So have any of you have any idea on this use case? Heard about this use case diagram, or what is a use case?
Yes, sir. Some functionality that the end user will use in a system. So, like for
Okay.
ATM, if we are giving the functionality like validation of pins or entering the pin, that will be use case.
You have already used that as a part of state model, no? How do you relate that? Whatever the ATM machine you have developed, you also had, no? Insert
sir.
pin, or insert card, pin, all those things. So
Yes, sir.
how do you differentiate? Is that use case there? No, my question is, you have used already these terms in other models.
Yes, sir.
So you're also using the same here. So how do you relate?
So it describes the behavior of the states.
Okay. Perfect. So we have seen, for example, if we take the telephone line. We have identified phone is ringing state. That is a state. The behavior while it is ringing, what will happen internally is what we are going to model in the interaction model, right? You have mobile phone. The state is ringing. While it is ringing, what you can do? You can go to the keyboard. You can add another phone number. You can do some activity. What you do while a state is ringing state, what all you can do? They probably describe the interaction, or they focus on the how you can do some of those activities when some state is happening. So probably if that minute level you want to bring, you go to the concept of a use case. The use case per se is a very low level. I can say a fundamental unit of a functionality. Functionality means here, you might have seen SRS document in software engineering, where software requirement specifications are given, where we have a requirements in the form of a functional requirements as well as a non-functional requirements. So our major idea behind use case is a functional requirement stage, majorly. Okay. When you take a particular system, for example, I take a login. When I enter into a particular website or particular safe domain, I will be asked to enter my login credentials. Based on that, I will be moving further. If it is a state diagram, I could have just portrait login over. On success, you go to the next level. On failure, you go to some other place. That's all the state diagram is going to do. But what my interest in use case is, okay, when you go to the login, what are the possibilities I can get? I may have a user ID problem. I may have a password problem. If it is user ID problem, I may be asked to sign up further. If it is a password problem, I may be asked to forget password, or I may be blocked by this website. Anything can happen. So those final details are what we are going to focus as a functionality of a system. When you go to that function, you go to that interaction model, that interaction situation, probably we call that as a use case. That's why we say use case is a very, very finer and finite type of a transaction between the objects, which will be the normally a fundamental kind of activity. So beyond that, you will not be able to find anything. You will go to that level. So that detail is going to be given. That is the case we call it as a use case. Use case means for like a test cases. You write test cases, right? In testing, you might have heard about test cases. What do you mean by test case? You write a particular testing behavior for every possible input. If I give 0 for 1, what will happen? If I give 2 for 1, what will happen? If I give 1 for 1, what will happen? So you can't assume always user inputs 1. User might give dollar, user might give character, user might give something else, but your system should behave. Probably I would like to draw your attention 10 years back when ATMs were there. Maybe you might have not used to experiencing them at that time, because we have seen somewhere in 2000 when ATMs first time came into the system, or mobile phones entered the market in 2000 to 2005. So if you take an ATM, when you insert the card, many times card used to be taken by the system. We never used to get back the card. Or cash, sometimes cash used to come, sometimes cash never used to come, still amount could have been debited, or the cash would have come off, or remaining might have not come, or some cash will come, it will be taken back. We had so many challenges in the initial years of ATM, because that would have happened because some use cases were not properly understood, or some use cases were not properly designed. But today, you don't see all these challenges. Everything is very smooth. It's very, very rare that your money is taken back by the system. In fact, you can see a disclaimer by the ATM. Unless you take the money, I'm not going to take. If you don't take, somebody else will take. Don't blame me. So system is coming to that level, meaning that you're able to write use cases of that nature. So these are all examples I'm talking about. That means use case should be to that final level. So how do you write unless you have a complete knowledge about the functionality of a system? So that's why we say that the analyst who is going to interact with the client when a project is given to a particular company, he or she should understand all this completely. So who is going to write the use case diagram? This is a system analyst. When you are a system analyst, your job is to completely understand the 100% details about the project. Why? If you understand that, you can write a better use case diagram. The minute you write the use case diagram, I in the next level, maybe in the design of a system or maybe in the implementation level, will get complete picture of the project that is required. Right? So class model is only overview. I may not get complete picture. I may just only get internally how things can happen between each class. Second, state model will give time bound or a lifetime, but use case will go to the last mile. Least required information also would have been captured. If I do that, probably use case diagram is going to be the one of the important diagrams in the SDLC. Who is going to be involved in this? The analyst of a company who is understanding the requirements of a client is involved. Not only he or she, but even the company people who are giving the project, they also will say, no, this is not the use case we want this. So they will fine tune. So both the client as well as the analyst will sit together and will complete the use case diagram. Once that use case diagram is given, then probably you and me who are the designers or implementers can easily implement. So that is the idea behind the use case diagram. Is it clear? Are you able to get the concept?
Yes, sir.
Yeah, that's why we say use cases mainly concentrate on the functionality of what is the functionality of a system. If you take a website, you go to a BMSIT website, let us say, there are so many menu icons. If you go to one menu icon, if you click, you should get it. So further, you will be able to get, and you should be able to come back. You should be able to have a smooth navigation. If all those things are done, I can say that use case is properly identified and developed for the benefit. Otherwise, what will happen? You go to a particular menu and you are unable to come back to the main menu, or you are unable to traverse back or navigate back to the previous menu. Then we say that use cases are not properly built. It is not user friendly. So when you want to make a system user friendly, you should have a proper understanding of the system and proper understanding of the individual requirements of the entire program. Then only you will be able to do. So if you do not understand it properly, probably as it happened 10 years back on ATM mission, those problems or challenges will occur or recur in the development. So slowly, yes, you have to develop. So when you go for a new project, even Aadhaar card, if you see, when it was done 15 years back, there were so many hiccups, so many challenges in doing that. So today the model is matured and Aadhaar card is given without any hassle. So any system will be definitely open to a lot of iterations, but as a designer, our duty is to how to minimize the errors and how to maximize the user friendliness so that the system will be more matured enough in dealing with the requirements of the clients or the end users. And second point of use case is mainly targeted at the end user level. Who are the end users? We are the end users of a ATM mission. My interest is go with a card, interact with the system, get my money. If that is the case, I'm going to the end user of that. So end user case, if you are able to target, remaining internal cases are already met. That means inserting cash, making sure that cash is properly updated. All those would have been properly done when use cases of end users are taken into consideration. So this is a bottom-up approach. So probably that way also we can perceive the interaction model or a use case diagram. So when someone asks about use case diagram is a very finer level, very detailed level of understanding of the complete functionality of a system. There might be 100 ways of looking at a small login. Maybe small login, if you take, you can write into a very big diagram of use case. As I said, login is successful, fine. If it is not successful, why? There might be reasons. Upon unsuccessful, what to do? A sign-in problem, or username problem, or a password problem. If password, can I give a new password? In the new password, how you are going to authenticate? You're sending a mail, OTP, authentication. You can make a login itself is a very big use case diagram. But if you go back, maybe again 5-6 years back, use case of a login was very simple. Login, check whether valid username, password. If not, send the user that you are not a valid user. Over. But today, there is a maturity. Use case of a login has taken a lot of changes. We are not going to leave until a proper login is done. We are doing authentication. We are doing two-step verification. We are allowing the user to sign in. We're allowing the user to create a new password. All the things are done at the same login use case. So that's what the concept we have been talking about. The functionality of every step of a system will be visualized or described through a concept called as a use case. Okay. Hope you all could able to understand the idea behind the use case diagram. Okay. Then sequence and all we'll see later, because right now our concentration is on the use case diagram. Okay. Yeah. Let me take this analogy. So there is a house here, and you as a owner of the house, your interest is how to use the house internally. In the sense, in a 30-40 site, how I can make my life comfortable or easier day to day. Say morning when you get up, you want to see sunlight. So let me have a space where sunlight is visible to me. After some time, you want to pray, do some meditation. You want a peaceful environment. You are worried about where that space is available at home. After some time, you are getting ready for your work without disturbing the people at home. So you want to have an independent place to get ready, or to provide privacy for each of the family members. And after that, once you come back, you want a place where to sit out and relax for some time. So you have some requirements. That is what the expectations of you. So when you are trying to build a house of you, you will be approaching an architect and you will be telling, look, this is what I want in a architecture from internally. So you already given your use case, right? Your functionality you have given, how I should be using the house. But architect, who is analyst here, he will take your input. Okay, you want 30-40 this way, and he will follow all the legal activities. What is legal activities? Local body will say you should have 2 feet, 3 feet should be left between your house and other house, and you should not use the road. That you may not be knowing, but he or she will be knowing. So they will bring all those feasibilities into the picture. Then they will say, look, you wanted a meditation room, but I can't give it as a 6x6. I can give only by 2x3, because all other area is blocked now, because as per statutory requirements, I have to do this. So your worry is how I will use my house to my expectations or to your requirements. The worry of an architect is how I can build a house as a trade-off that you should be also be happy as a client. And second, even the statutory requirements of the local authority is also met. And third important concept for analyst is how I can build this house, which will sustain for 100 years. He is worried about foundation, he is worried about the columns, he is worried about the footing, he is worried about the material. He has to think so much. So this is how the concept of a use case is. So use case from a user perspective is different. Use case from analyst perspective is different. But system is same. House is a system here. For that system, you being an end user who is going to live in the house for some time, your requirements are different. Your expectations are different. At the same time, the analyst, he will be viewing not only from client perspective, but also from the construction or the design of a system perspective. Whatever you ask as a client may not be possible to be implemented, right? You wanted, say, 10x10 place for your meditation, may not be possible. You may give, say, 3x5. So what you want may not be feasible in the given constraint. What is the constraint? You have only 30-40 site. In 30-40 site, you will be losing some 30-40 square foot for some other purpose. You're left with 1,100. In 1,100, how much to build? How many floors? All those things are going to be considered. So functionality is viewed from multiple perspectives. The concept here is you as an end user, your perspective is different. Analyst from a designer or architect perspective, their perspective is different. So use cases need to be of that detail. So when I say use case or functionality of a system, it should be from both the ends. It is from the end user perspective, but also from the analyst or architecture perspective. Okay. So that's how the concept here is. So you are worried more about how I can use the house, right? Where I can use, where I can keep my things, how comfortable it is, daily should not be disturbing me, all those activities you have, right? So this is also your use case is different and their use case is different. So perspectives are different. So this is a concept of a use case. So functionality, from that perspective, we have to look. So any clarity required here?
No, sir.
Yeah, fine. So what we have to understand here is use cases are completely drilled down to the functional requirements. Maybe a non-functional requirements also to some extent can be carried out. Otherwise, basically, they are requirements which are from the functionality perspective of a system. Okay, how the system can be used or what are expected by the system rather. This is how the use cases are going to be identified. So requirements, we know they are functional as well as non-functional. Functional requirements are what we are going to look at as per the use case diagrams are concerned. You can also consider non-functional as the case may be. Okay. Yeah, so we know we have seen in detail what a use case is all about. Now let us come to the use case diagram. So use case diagram. So like any diagram, like we have seen state diagram, use case diagrams also will show the functionality in a UML form, the picturization. So what is the picturization? The picturization is from a user perspective or the functionality perspective, right? So if you look at the concept is to have a diagram which describes or depicts relation between the type of end user and type of use case. So you have understood now use cases are from the user perspective majorly as an end user 99% or maybe other users who are all related to that functionality. The same house construction, same 30-40 site, but how many users are there? You are the resident, you are one of the user. The local authority, they are also users because if you do not construct a house properly, the neighbor will come and complain. So in that case, they also will have a say in the functionality of your house. You might have constructed full house without even leaving an inch. Tomorrow they will come and demolish. That's what we see in the market today. So that means they also have a say in the functionality of your house. Your functionality of a house is disturbed, right? So you are the owner, you are the resident, local body, the constructor who is going to construct, maybe the architect. So many people will have a say in the functionality of a system. So we call them as actors. So actor is nothing but the one. It can be a person, it can be an entity, it can be another system, it can be anything. Actor is the one who is directly involved in the functionality of a particular system. That is what the plain terms you can understand. So a actor is going to interact in the system, or the actor is going to participate in the functionality of the system, or the actor is going to play some role in the execution of the system through its functionality. Probably we can say them as a actor. Fine. Now I am an actor. Now I will be interacting. When I interact, what way I am going to interact? I am going to interact through some use cases. For example, if I am a owner of a house, I will be interacting with the house as a resident. So I, as a owner, is an actor. Since I'm going to reside in the house, residing becomes a use case. I'm going to reside in the house, right? Similarly, the town planner, the local authority, they're also actors. What way? They're not residing in the house, but they dictate terms. They ensure that your safety is taken care. They ensure that your house is built as per the norms. They're going to be implementers of the local requirements. So they're also involved in the use case of your system, which may be in the different form, maybe ensuring that the legal items have been met. So this is how the concept of a actor and use case. So there are two things that are going to be there in the use case diagram. One is an actor, other one is a use case. Okay. So these two are going to interact with each other through a concept called as a association. So actor interacts with the use case, or actor will be having a functionality with these use cases through an association called as a line, a simple line, like you have seen a state diagram transition, we'll have a arrow mark line. That is one pointed line, unidirectional line towards from actor to use case. Then all these actors and use cases are put in a boundary. When I say house is having its own boundary. When I say library management system, it has its boundary. When I say student management system, it has a boundary. Boundary means you are going to construct or develop or design a system considering certain assumptions or considering certain aspects. You are not going to create a system for open end. Second, you are not going to construct system for one time. System is prone to changes. System is required to be modified. So when you are developing, you should be working within the boundary. You cannot keep it as a open-ended. So these are the 4 things now what you should remember when you are working with a use case diagram. One, what is the boundary within which this functionality is visualized? Second, who are the actors who are dealing with this particular system? What are the use cases through which these actors are going to interact? And important one is how these actors and use cases are related to each other through the association. So these are the 4 points that we have to keep in mind. So probably this is just introduction of use case diagram. We can see some more data and activities in the next class, and we can take some models and represent how use case diagram can be written. So with this, let me stop here. So quickly, let me take attendance. If you have any doubts, meanwhile, you can let me know. Number 1.
Yes, sir.
2.
Yes, sir.
3.
Yes, sir.
4.
Yes, sir.
6.
Yes, sir.
8.
Yes, sir.
9.
Present, sir.
10.
Yes, sir.
11. 12.
Yes, sir.
13. 14.
Present, sir.
15.
Present, sir.
16. 17.
Yes, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
What, Arshit? You are not regular. Any challenge?
No challenges, sir.
But we hear you are not attending classes regularly. Be aware that your attendance is important, whether it's online or offline. You have to maintain the minimum requirements. Be careful. Okay. Be in touch with your class teachers and course teachers. Ensure that your attendance is up to the mark. 21.
Yes, sir.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Yes, sir.
25.
Present, sir.
26. 27.
Present, sir.
28. 29.
Yes, sir.
30. 31.
Yes, sir.
32.
Present, sir.
33. 34. 35. 36.
Present, sir.
37.
Present, sir.
38.
Present, sir.
39. 40. 41.
Present, sir.
42.
Present, sir.
43.
Present, sir.
44. 45. 46.
Present, sir.
47. 48. 49.
Present, sir.
50.
Present, sir.
51.
Present, sir.
52. 53. 54.
Present, sir.
55.
Present, sir.
56.
52 present, sir.
56. 57.
Present, sir.
58.
Present, sir.
59.
Present, sir.
Sir, 52 present, sir.
Yes, yes. Yeah, thank you. If you don't have any doubts.